Hopefully, do not see me, just you see the laptop is getting upside down. Don't be worried. Also, here. One. Okay. Linda, by the way, did you submit your homework to me?
No, because I don't know how to send it to you.
Oh, email it to me if you can.
School college.
Oh, yeah, sure.
Oh,
Okay, guys. Today, before we start with the new lesson, I'm just gonna give you one simple, I should say, exercise to warm up your brain on the things that we did, I should say, so far. Because the today's new lesson is that I just want to use the power reduction to reduce the identities. That's a new technique which you're going to learn. But before that, we need the concepts that we learned in the past. I'm just going to give you one quick exercise that you please work with it, and this is going to be about the fluid mechanics. Those people who just want to just study, I should say, mechanical engineering, they will have lots of fluid mechanics concepts. And I'm just going to tell you that, for example, in the fluid mechanics, sometimes you have this equation that gamma 1 V1 sine alpha is equal to gamma 2 V2 sine alpha. Everybody can see this color?
no.
No.
No? Oh, okay. Let me change the color which I had. Yeah, it's this one. Gamma 1. How about now? Is it better now?
Yes.
Great. Sine alpha minus beta. That's essentially the thing which you will see that in fluid mechanics. Where is my ruler? That's essentially what you will see in fluid mechanics. Which essentially we do not take care of gamma 1 and gamma 2. They call it, I should say, the viscosity, I should say, constant. This is in the fluid mechanics. And V1 and V2 are, I should say, the velocity of the fluid. And we are just going to use that identity in the fluid mechanics to state that if, to show that if gamma 1 V1 equals to gamma 2 V2, we are going to show that if this identity holds, that the viscosity times, I should say, the velocity of each fluid is going to be the same. We are going to show that we have this relationship, that the cosine of the beta minus cotangent of alpha sine beta is going to be equal to 1. That's the thing that you're gonna do. It seems that all my markers, they're dying and I have to change them, all of them. Look at that. That's the thing which we want to do then. We just want to show that if actually you are going to do that at the beginning of the class, this relationship is going to hold. Okay, guys, you know what's the task now? You're going to come here and show that this is relevant in fluid mechanics, that if viscosity and velocity gamma 1 v1 sine alpha equals to gamma 2 v2 sine alpha minus beta, if gamma 1 v1 equals to gamma 2 v2, you are going to prove that cosine beta minus cotangent alpha sine beta should equal to 1, based on the sine and the sum of the sine of sum and the sine of I should say sum of the angles. Then it's going to be very easy. Please spend a couple of minutes, and that's a good reason that you go back to your previous notes, you warm up your brain for the thing that we're going to do right now, then in 2 minutes. I'm just going to give you 5 minutes to just prove this identity. But everyone know what's going to happen? Yes? Mingje, Linda, Sean, are you there?
Maybe.
Yes.
Okay. Linda, just look at this identity, gamma 1 V1. Okay.
Yes.
Put gamma 1 V1 equal gamma 2 V2. Expand sine alpha minus beta. Show this identity exists.
Oh, okay.
Okay. Super.
Yes.
Super. Makes sense now, huh?
Yeah.
Awesome. That's very easy, Linda. But it's good that you check your notes back, because we need your notes then before we start. I give you 2 minutes, so 3 minutes to do that thing. Okay, guys, are you done? It's very easy exercise. I'm gonna change my markers. Let me put them to the garbage. I do not use them at all. Page 1. This one goes to the garbage bin. Okay, guys, are you done?
No.
Not yet?
Yeah.
No worries, take your time. Okay, how far you gone so far? Okay, guys, I'm just gonna take this paper aside. Okay, shall we continue?
Okay.
Okay. Linda and Sean, if you haven't done that, please do that a little bit later. Just put it aside, then do that as a homework then.
Okay.
But it's a very easy strategy because if you want to do that, I advise you when you want to do that, just and the main equations, just put gamma 1 and V1 with gamma 2 and V2 equal, then they are going to be equal, then expand, just they can be removed from both sides. Then you are going to reduce this equation to the sine alpha should equal to the sine alpha minus beta. This color is also dying. Let me put this aside. Then what's going to happen, you can expand sine alpha minus beta and just divide both sides by the sine alpha. Sounds good? Then it becomes sine alpha equals to sine alpha cosine beta minus cosine alpha sine beta, which is sine alpha. You divide both sides by the sine alpha, you prove this identity. Make sense? Yes, everyone?
Yeah.
Okay, now let's go back to do the second thing here. And in order to do this, we are just going to review some of the identities which we have done in the past. Then we introduce the new identity. Then we talk about the power reduction, which is essentially the main topic of today's lesson. The concepts of the power reduction. Okay, so far, based on the things that we learned, we introduced three identities which they expanded the trigonometric ratio of sum or difference of the angles. For example, we said that we talked about, let's say, for example, the first one that we talked about, for example, the cosine of the sum two of the angles. What did we say? Last week we said that the cosine of alpha plus beta equals to what? Based on the things that we learned, it was expanded as the cosine of alpha times cosine of the beta minus what? And remember that cosine alpha, cosine beta, there are two ratios that they are being multiplied together. For example, imagine you did multiply 2 times 4. Two different identities, which everyone is a ratio, is being multiplied with each other. Then we said that because this is cosine, for the cosine, if this is plus, the angles are summed, we just subtract them. Then because sine of alpha times sine of beta. Okay, let me just put my, I should say, this up, my sleeves up. Means I'm just getting very serious for the course. Okay, now that's what we talked about that a couple of days ago. And imagine that we come here to say that, okay, based on the things that we know, imagine, guys, the thing which is going to happen here is that, imagine that I say to you that what happens if alpha, which is my angle or the arc length, should be equal to beta. That's right. Then what's going to happen? Essentially, this identity which I derived here, it reduces to this, reduces to, say, let's say, for example, becomes the cosine of alpha plus alpha, which is essentially what? Becomes what based on that? Becomes the cosine of alpha times cosine again alpha, because beta and alpha now are the same, minus sine alpha sine again alpha, because as I said, we look at this identity in such a way that the alpha and beta are both the same. They are both equally the same. Then instead of writing cosine of alpha plus beta, I was writing the cosine of alpha plus alpha. That's essentially what's happening right now. Then what's if I just want to start back again from this, I'm just gonna do some kind of algebraic, I should say, simplification. From this identity, if I want to move here, how can I show that? I can show this like what? I can show that as a cosine of what? Of alpha plus alpha becomes what? 2 alpha equals to what? Cosine alpha, cosine alpha. What is that? For example, A times A becomes how much, Mingzhe?
2 cosine alpha, sorry.
Cosine is squared, huh?
Oh, yeah.
Yeah, because you remember that, for example, A times A becomes A squared. Cosine alpha becomes cosine squared of the alpha. That's right?
Yeah.
And essentially the same thing. How about this one? Sine alpha times sine alpha becomes how much?
2 cosine alpha sine, oh, sorry. Sine square alpha.
That's so true.
Yeah.
Sine squared of alpha. Yes, Linda?
Yes,
You're doing fine so far?
yes,
Awesome. How about you, Sean?
Yes. Yes.
Good morning.
Oh, good morning.
Ah, okay. Nice. Okay, and now then we are here at this stage. What's going to happen now? So far, it seems that we have developed one identity, and the identity which we have developed for that is this one, that the cosine. Let me change the color which I had. And the identity so far is that is this the identity of double angle? They call that double angle, which is gonna, oh my god, my markers all are dying. I have to change them. Which it means what? Which it means that the cosine, the double angle, we derive this identity. It's a raw identity which we may not be able to use that in most of the places, but instead we have to just submit it to, I should say, reduce it to a simpler form. And now, I developed this identity directly from the one which I knew from the past, which is the cosine of the sum of the angles. And the problem right now is that here. Previously, if you remember, in the function 11 course, you derived this identity that cosine squared of alpha plus sine squared of alpha equals to what? Equals to 1, correct? Then I can use this one here and rewrite this expression in a very simpler form. What do I mean? I say, okay, I write, for example, the cosine of 2 alpha should equal to, instead of cosine alpha and sine squared of the alpha, normally in the trigonometry, it's very easy. Whenever you see, for example, any of cosine and sine ratio, which we'll learn that they are the most fundamentals of the trigonometric ratio, because by using these two these two ratios, you can build up 4 other ratios by using them. And whenever you see that, the even powers, even the power can be 4, the power can be all powers, even with the odd powers. But with the even powers, it's much easier sometimes. Even with the odd powers, this is feasible then. But we will see that today, how we use these power reductions. Normally, the basic one is that when the power is 2, you can use the first identity that we learned to express the cosine in terms of the sine, or sine in terms of the cosine. Imagine that from this identity, what is the cosine squared of the alpha? It becomes very easy. I can just take sine squared of the alpha to the other side. Then the cosine squared becomes what? Becomes 1 minus sine squared of alpha, correct? Minus, and the rest of this identity remains intact, and I do not change it at all. It becomes my sine squared of alpha. And now, look at that. I can expand it a little further, and it becomes 1. I keep the 1 where it is. And I have minus sine squared of the alpha minus sine squared of the alpha becomes 1 minus 2 sine squared of alpha. Then as a result, we have this identity that the cosine of 2 alpha becomes this. This is, I should say, a simpler format, a version 2 of the identity, which we got that, I should say, on the top, that the cosine of 2 angles becomes 1 minus sine minus 1 minus 2 sine squared of the alpha. You got it, guys? Page number 2. Any questions?
No question.
No questions? Okay.
No question.
And now, the same thing that we can do is this. So far, we said that the cosine squared of the alpha what I learned here, that it was this one, that the cosine, guys, you see this color which I'm writing, huh? You do not have any problems with it, huh? Was cosine squared of alpha minus sine squared of alpha. And imagine now, at this stage, the previous one, I used the fundamental identity that 1 equals the sine squared of the alpha plus cosine squared of the alpha. I used that identity to express the cosine in terms of the sine. Now I'm just going to do the reverse. I say that I keep the cosine squared of the alpha intact where it is, minus, for the sine alpha, I'm going to put 1 minus cosine squared of the alpha. This is what you saw on the previous identity, because now you're expressing sine squared in terms of the cosine squared based on the fundamental identity. Then what's going to happen now here? The thing which is going to happen is this. Then you have 1 becomes cosine squared of the alpha minus 1 plus cosine squared of alpha, which you will see that at the end, that you can write cosine of double angles, which is going to be 2 alpha, should equal to what? Should equal to, you have cosine squared of the alpha, you have cosine squared of the alpha, becomes 2 times of cosine squared of the alpha, and you have minus 1 left. And that becomes, I should say, the second identity that we developed it so far. Okay, any questions, guys, on this?
Nope.
Everything is clear?
Yeah.
Everyone, for Mijay also, for Linda?
Yeah.
Yes.
Awesome. Guys, have you seen this stuff in function 11?
No.
No?
No.
Okay. If you have, oh, I thought maybe I'm reviewing it, but you haven't seen that before, huh?
Yeah.
Okay. Now, it was page number 3, I think. That's right, page number 3. Then if I want to sum up, let me change my colors. I have about some new markers. Let me just bring the new ones. About them yesterday night. Let me use the new ones because these ones, it seems that they're already dead. Now, then if I want to summarize the things which we learned, I'm going to summarize it in this way. Then the first identity that we learned, it was this one. It was the cosine of 2 alpha was cosine squared of alpha. Guys, do you see these colors?
No good.
Not good? Back to alpha. This is the things that we saw. And also the second identity was this. We said that the cosine of 2 alpha, is it clear, Linda, now?
Yes.
Awesome. Becomes For this identity, we saw that we have this one, 1 minus 2 times sine squared of alpha. And also, we learned the third identity, that the cosine of 2 alpha equals to 2 times cosine squared of the alpha minus 1. Then we just learned this identity. I call them identity number 1, number 2, and number 3. Okay, guys, before I just move on to do some example and just continue with the other identities, please listen to this very interesting fact. Especially if you look at the identities number 2 and number 3, you see something very interesting. Please look at the left side. What is the argument of the cosine? It's what? It's 2 alpha, correct? But take a look at the right side of the identity which I have written. I had cosine of 2 alpha, and I was able to reduce it into the identity which only involves just only what? 1 alpha. You see this? I had 2 alpha here, and now I have the alpha on the other side. And that's one of the, I should say, very fundamental property of the trigonometric identities, that always you are able to just make the identity that half, it expresses your angle with half of it. Correct? For example, we're going to talk about more of this, but also look at the other one. I have again to the other side, I have the cosine of the 2 alpha, but on the other side, I was able to express that in terms of just only the alpha itself. That is a very crucial property of trigonometric identities that we are going to expand on it more in future and use that. For example, if we use, for example, you do not have to have, I should say, we talk about more of this property when I talk about the half of the angle identity, and you see that how important is these two characteristics. Okay, any questions, guys?
Nope.
No question.
Awesome.
No.
Awesome. Okay, now. Let's do one easy example. Then one identity, then I move on to a new lesson. Okay, now imagine that I'm just giving you the alpha as, let's say, 5 over 8 radians. I'm giving you the alpha like that, and I just want to find, you please find the cosine of 2 alpha. Okay, are you done? Who is done? Okay, let me also start doing this. Look at that. Cosine of 2 alpha. And I know what is the alpha. First of all, I'm going to write the identity, which is relevant for the cosine of 2 alpha. Based on the things which you learn, for example, I can use this identity, cosine of 2 alpha, as what we derived 5 minutes ago, becomes 1 minus 2 sine squared of the alpha. You see, 2 alpha, alpha to the other side. You half the angle. I'm just going to use that identity and say cosine of 2 alpha becomes 1 minus 2 times the sine squared of half of the angle, which is going to be the alpha. That's the starting point. That's the starting point. Then as a result, the cosine of 2 alpha, and you know what is your 2, becomes 2 times, the alpha is 5/8, which is your 2 alpha, becomes what? 1 minus 2 times sine squared of alpha. What is your alpha? 5/8. Correct? Okay, if it was radians, sorry, I just had to just put the pi over here. Because this is radians, you have to put the pi there. Then at the end, what happens then? Then you just want to decide what is the 5 pi divided by 8. How much degree is that? 5 times 180 divided by 8. How much do you get? Let me put that in the calculator. Five times 180 divided by 8 becomes 112, and you can just, it becomes around in the second quadrant. Then wherever you are here, it's totally fine. Then you can use a calculator to see what is the sine of 5/8 and just subtract 1 minus 2 times of it. Then you see that how this one is reduced to half of the angle. This is 2 here and we have 1 there, and that was the purpose of this exercise. Okay, for the other exercise, I just want to ask you please to prove this identity. Let me write this identity like this. That's the cosine of 3 alpha should equal to 4 cosine cube alpha minus 3 cosine of the alpha. Guys, please take some couple of minutes to prove this identity, that the cosine of 3 times of the alpha equals to 4 cosine cube of the alpha minus 3 cosine of the alpha. Okay, guys, are you done now? Yes? Minjay, Linda, Sean. Minjay,
Yes.
are you there?
Yes.
Are you done?
Yes.
How about you, Linda?
Finish.
Oh, you're finished. That's great. Okay, it's going to be very easy. In order to prove this, as you have done, you just write cosine of 3 alpha. You write it as a cosine of 3 alpha becomes 2 alpha plus alpha. Then it becomes what? Becomes what? What do you think it's going to be? Becomes cosine of 2 alpha cosine of the alpha minus sine of 2 alpha sine alpha. Then you write again like what? Cosine of the 2 alpha. Cosine of the 2 alpha becomes what? Guys, are you there? Then
Yes.
becomes what? Becomes cosine squared of the alpha minus sine squared of the alpha times cosine of the alpha minus sine of 2 alpha times sine of the alpha. And now we have at this stage now, we are looking at this, we see that we have sine of 2 alpha. You see this, guys? Sine of 2 alpha, that's where we are stuck now with. What is the sine of 2 alpha? How much is that, Mingji? Sine of 2 alpha?
2 sine alpha cosine alpha.
Fantastic, fantastic. Becomes 2 sine alpha cosine alpha. Why? What's gonna be like that? Linda, you know why?
Maybe no.
Maybe no. Okay. Look at that. That's a good reason. We just talk about the third identity we're gonna have today. We come back to this. We prove this in a couple of seconds. But now we are stuck at this point. That. Give me 1 second. I should say this one. Okay, go to this. Okay, and now look at that. Now we are at this stage, and this stage is a kind of, I should say, a kind of a puzzle for us. We have the sine of the 2 alpha there. What we were planning to do initially, we were planning to prove this identity. Sorry guys, I have to use my new markers. They get old and you will see what I'm writing there. Okay, let me use the new marker. Look at that. You just want to prove this identity, that what is the sine of the 2 alpha. In order to show that, I'm just gonna draw your attention back. I'm gonna go to the new page, and at the new page, I'm gonna write some stuff. Then, let's see. Okay, what did I have before? I had previously, for the sine of 2 alpha, we were talking about that. In the past, we learned what? We learned that the sine of alpha plus beta equals to what? What is that, Linda? It's sine alpha cosine beta plus cosine alpha sine beta, right?
Yeah.
That's what we learned before, huh? And now, Linda, imagine that this strategy which we had, we say that when we say that the sine of 2 alpha, when I have sine of 2 alpha, let me, oh my God, where is my ruler? Hold on a second, guys. I come back. I just need a smaller ruler. It seems that I have lost it in home. Give
No
me 1
problem.
second. Okay, I cannot find it, it seems. Okay, and that's the thing. We say that, okay, the sine of alpha plus beta, and when we are looking at the sine of 2 alpha, the thing which we had on that identity is essentially like that. We say that what is happening if alpha should be equal to beta? What's going to happen there? Then in that case, Linda, what's going to happen? We say what? Sine of 2 alpha, correct?
Yeah.
It essentially becomes sine of alpha plus alpha. Let me write it like that first. Then becomes what? Becomes sine of alpha cosine of alpha. Because beta is alpha. Yes, Linda? Plus cosine of alpha sine of alpha. Yes, Linda? And now, let's simplify that a little bit more. I have sine of alpha plus alpha. What is that, Linda? Sine of 2 alpha, correct? Yes, Linda? Equals to what? I have sine alpha, cosine alpha, sine alpha.
1.
That become 1?
Mm, yes. 1.
Think a little bit more. I have sine alpha, cosine alpha. Is it the same thing as cosine alpha, sine alpha?
Mm,
Imagine Linda and Sean, Sean and Linda. You two are the same, huh?
yes.
Imagine that, Linda. Sine alpha is going to be you. Cosine alpha is going to be, for example, Sean. Then if it's going to be Linda, Sean, after here I have Sean, Linda. Is do the same thing?
2 sine alpha.
Fantastic, brilliant. Becomes 2 sine alpha and what?
2 cosine alpha.
That's right. Only one is enough because Sean, Linda plus Linda, Sean becomes 2 times Sean, Linda, huh?
Yes.
Yeah.
That's right. Fantastic. And now you see that, Linda, we develop a third identity that we were looking for. And that identity is this, that the sine of 2 alpha equals to 2 times sine alpha cosine alpha. Guys, but in the meantime, I'm just going to ask you, who is next speakers? Who's going to be the first one? Is it Mingjay? For the logical hierarchy? Yeah, Mingjay, is it you that you're starting the first one or no?
No, Oliver is the first one.
This Friday,
He's doing,
huh?
oh yeah, I'm doing the
Ah.
next Monday.
I can't wait for the talks, guys. Okay. Actually, the thing that you're going to talk on your lectures, that's something which has won a Nobel Prize in physiology. You are dealing with something which won a Nobel Prize. Isn't that exciting? Okay, now, then Linda, you see that I developed this identity that the sine of 2 alpha is 2 times of sine of alpha cosine alpha. Please take care of this part, guys, that 2 alpha is this in front of the trigonometric ratio, and now this is alpha, the half of the angle in front of this ratio. You see that?
Yeah.
No? And that's important. We call that the sine of 2 alpha then. Okay, now I'm going to go back to the same thing which I did before. The same identity. We finish this, then we take a quick break. Linda, the identity was what? The identity was this one, that the cosine of the 3 alpha, we have to show that equals to 4 times cosine 3 alpha minus 3 times cosine alpha. And the problem, as you can see, not the problem, something very interesting is that I have 3 alpha, the angle is 3 times. Look at this angle here. Look at this angle here, Linda. The angle here is 3 alpha, but the angles here is alpha. It's alpha. You see that?
Yes.
That's how you crush the alpha. For example, this is a piece of bread, 3 alpha, imagine that's a piece of bread, and you just crumble the piece of bread to smaller parts, and now that's the alpha. This is the beauty of these kind of identities that you're working with. Sometimes you want to express a trigonometric ratio with a reduced angle. That's the crust of the thing that we're going to learn today. We're going to talk about that more after the break. But guys, as you will see even from this example, the purpose of the lesson for today is that we are just going to come with some kind of a global strategy to reduce the angles and arcs to a smaller one. For example, you start with the 3 alpha, you reduce it to a smaller alpha. For example, 3 alpha is, you put them on a diet and it becomes smaller and smaller. That's the global, the strategy that today we are working towards. And now, based on that thing, I should say, Linda, we said that the cosine of 3 alpha, I can write 3 alpha as what? As 2 alpha plus alpha. Is it correct? Because still, if you can see, 2 alpha plus alpha still becomes what?
3 alpha.
So correct?
Yes.
Then I see that it doesn't harm anyone. It's an innocent, I should say, strategy if I write 3 alpha as 2 alpha plus alpha. So far correct?
Yes.
And now, what is, I should say, Linda, the formula for cosine of 2 angles that we learned? I need this one. Do you remember that from yesterday? That the cosine of alpha plus beta equals to cosine alpha cosine beta minus sine alpha sine beta, right?
Yeah.
Okay, if that's right, I'm going to use this one. I'm going to imagine that 2 alpha is going to become my beta and alpha is there. Then I expanded it. Becomes cosine of the 2 alpha times cosine of the alpha. But because this is cosine and this is plus, it's going to be the reverse, becomes to minus. And you reverse it to the sine of 2 alpha, but sine of the alpha at the end. Correct?
Yes.
So far, so good, Linda. No problem.
Yes.
Yeah, you are totally fine.
Yeah.
Fantastic. And now, I have this one here, Linda, that the cosine of 2 alpha, and I have sine of the 2 alpha. This is the beautiful thing in, I should say, in this identity, that in expanding this, I ended up with double angles. Look at this one and this one. I had a smaller ruler. The smaller ruler seems it's missing in home, and I'm using with a 50, almost half a meter ruler right now. Okay. And Linda, look at this, Sean and Minjae. Here, we have now cosine of 2 alpha and sine of 2 alpha. We call that double angle. Double angle, I should say, identity, double angle incidence, double angle ratios. That the angle which we have is multiplied by 2. You see the difference, Linda?
Yeah.
Now, when we see that the angle is multiplied by 2, it gives us the clue that the thing which is happening now is that we have to use the identities for the double angle. We derived it today, Linda, that the cosine, where is my notes? Here, we derived it today, Linda. In your notes, you can find it that the cosine of 2 alpha they have three identities for it. Cosine squared of alpha minus sine squared of the alpha. That's the basic identity. I wrote it like that, huh?
Yes.
That's right. And now, what else I'm gonna do? Also, I have sine of 2 alpha there. Let me write it way, it's that. It becomes like equal to, let me bring it. Guys, what time is it now?
10:06.
Okay, it takes 4 minutes. Then in 4 minutes, we go for the break if you are getting exhausted. Then Linda, looks what's happening out there. What is the original problem? Cosine of 3 alpha, huh?
Yes.
You see the colors?
Yes.
Awesome. Then you see that, Linda, the cosine of 3 alpha equals so far to what? So far to these ones which I have written. It's cosine squared of alpha minus sine squared of alpha times cosine of the alpha minus what? I'm going to write it here, the minus. I have not enough space. Sine of 2 alpha times sine alpha. What is the sine of the 2 alpha identity which you learned right now? Your example of the Sean and Linda. Sine of 2 alpha becomes 2 times Sean times Linda, right?
Yeah.
Then becomes what? Becomes minus, I write 2 times sine alpha cosine alpha, which is one of you is Sean, one of you is Linda. What I have at the end, Linda, it's multiplied to what? To sine alpha, correct?
Correct.
Okay, I have to the sine alpha there. Ah, seems a little bit nasty looking expression, right?
Yeah.
Seems everything sine alpha I have there, and I have also cosine, the sine squared alpha there. Okay, what do you think, Linda? What's going to happen right now? Look at this one. Cosine squared alpha minus sine squared of the alpha times to cosine of the alpha. And Linda, look at here, the one which we have. I ask you, look at that. Guys, everyone there, Mingji and Sean?
Yes.
Yes.
From this stage, you can do whatever you want. You can right now express cosine. Wherever you see cosine squared of the alpha, the first thing which it comes to your mind is that you can express that in terms of the sine squared using the identity that the cosine squared plus sine squared is equal to 1. Now you can just change cosine in terms of the sine of alpha, or reverse side, you can express sine squared in terms of the cosine squared. Then both becomes the same. Both approaches correct. But in this example, you are looking for a term which it has cosine to the power 3 of the alpha, right? Then as a result, you notice that you have cosine multiplied to this expression. And the chance is very interesting for you in case if you can express cosine squared of the alpha in terms of, sine squared of the alpha in terms of the cosine, then as a result, you have the cosine is expressed into the power 3. That is right? You understand what I'm talking about? That's right.
Yeah.
Imagine, Linda, for this sine squared of the alpha, write 1 minus cosine squared of the alpha. I mean, for this one. For this sine, let me, this identity got much bigger than I expected it. And I plan to finish it before we go to the break. Guys, are you very tired now? Can you stay for 5 minutes?
Yes.
Yes, awesome. Okay, you see this, guys? You see the paper over there?
Yeah.
Yeah? Okay. Then what I'm going to do right now, Linda, I'm going to write cosine of 3 alpha. That was a thing which I started with. And I'm just going to write cosine squared of alpha. But Linda, at this stage, I'm going to write minus sine squared of the alpha as what? As minus 1 minus cosine squared of alpha, right? Because I know 1 equals to 1 equals to cosine squared plus sine squared, right? And now I have this one here. I have this one here, which this one is multiplied to what, Linda? Based on the thing which you will see. Huh? Multiplied cosine alpha. Yes, Linda?
Yes.
Yes. And becomes what? Still I have minus 2 times sine alpha, which is Linda, for example, times Sean. Cosine alpha times sine alpha. Okay. Now, good, Linda, look at this one. The thing which I have written inside this parenthesis can be reduced to what? To 2 times cosine squared of alpha minus 1, right?
Yeah.
A very simple algebraic, I should say, notation. Then what's going to happen now? If I expand the cosine alpha, it becomes like that. I do not need that page anymore. And I'm going to start like this. Say that. Okay. From the first expression, Linda, what is left? It's left 2 times cosine squared of alpha minus 1, right? Which is multiplied to what? Cosine of the alpha minus 2 times sine alpha cosine alpha times sine alpha, correct? This is a step by, yes. Linda, are you fine?
Yes.
Good. Then what's going to happen now here? I expand, this one goes inside, becomes what? Becomes 2 times. Look at that. I have cosine. Cosine is going to be multiplied to this, and also is going to be multiplied to this. Becomes 2 times cosine cube of alpha minus cosine of alpha. And what else do I have? I have sine alpha, which is multiplied to this, becomes minus 2 times sine squared of alpha cosine alpha. You see that, Linda? When you multiply this to this one becomes sine squared of the alpha times cosine of the alpha, because sine is multiplied to that expression. Is it okay for you? Linda? Linda?
No, Linda is last. Oh, she joined.
Linda left.
Yes.
Are you fine so far?
Yes.
Okay. Then what's going to happen now is that I have the first expression which I need, and look at this one here again. I have equal to 2 times cosine cube of the alpha minus cosine of the alpha minus 2, and I write sine alpha as what? 1 minus cosine squared of the alpha times cosine of the alpha. For the sine squared of the alpha, I write it as 1 minus cosine squared of the 1 minus cosine is good. Cosine is square root of the alpha. It's too much trick coming through. But are you okay so far, Linda?
Yeah.
Are you sure?
Maybe I need.
I felt that you got lost somewhere.
Yeah.
Yeah?
Yes.
Okay. I think you know what's the best thing to do, Linda? The best thing is that to take a break. When we come back from the break, we are not in rush. We can finish it and then make sure that you got it. Huh?
Yeah. Okay.
Yes, that's right. Linda and Mingji and Sean, what do you think? Is it a good time for the break?
Yes. It's
Yes.
Okay.
Good. Guys, please enjoy your break for 15 minutes. What time is it now? Today, we're going to take a
10:16.
break for 16 minutes, guys. We have 1 more minute break. Yeah, please come back now at 10:32. Is it good?
Oh,
Yes.
Then I finished this part for everyone to make sure that we got it. This identity was so much tricky that I thought that. Okay, then guys, see you
Okay.
in 16 minutes.
See you.
Okay, see you later. Bye. Bye. لپتاپم پوکی خاموش شد. برو یه نسکافه من بلکه دقیقه برم بیرون بردم. آبیوز ورزش کنه غلط شد. گفتم چرا انقدر داغونم امروز. واقعا داغون شو غصه میکنه حالا. سامانتانی شانس داشت در نمیاد. قبلا که بود بزرگی میکرد. ببین تاثیر یادگیری وقتی دختر پسرا توی کلاس با همه چقدر خوبه. در حالی که تو ایران دختر پسرا میبینی کلاس جداست. اینو ما مگه دختر پسر با هم میخوندیم الان من فکر کنم تو ناسا بودن. بابا اون همزاده‌ای که بابا به نظر من از خر میکنن. سرت Okay, guys. Hello again. Guys, are you back from the break?
Yes.
Okay. Okay, let's move on. Linda, are you back?
Yes, teacher.
Awesome. Are you? Oh, you just joined, huh?
Yes.
Awesome. Okay. How far did we go for the previous example? Okay. How far
Can I
did we
take
go?
picture, teacher?
Sorry, what?
Can I take picture?
Oh, yeah, yeah, sure. By the way, Linda, I just post every day the video lectures.
Okay, okay. I read, teacher.
Okay. You can take a picture, but in case also, if you want, you can watch the videos then.
Okay.
Okay. Does any other teachers here at the school, they record the videos and put it on the Schoology website?
No,
Nobody else does that?
nobody.
Oh, okay. Guys, let's wrap up very quickly. And Arya, I'm gonna tell you quickly what happens. Please take a picture and also check that thing online. Then, because we just moved so fast on that topic, then we were
Okay.
planning to also, Linda, please you listen what happened so far. We were trying to prove this
Yes.
identity that the cosine of the 3 times of the angle is 4 times of the cosine cubed times alpha, 4 times the cosine to the power 3 of the alpha minus 3 times cosine of the alpha. We expanded this as this. We showed that, okay, it's become cosine squared of the alpha minus sine squared of the alpha. We ended up to here. And I think at this stage, we said that after the break, we are going to continue working on it. Okay, it was an identity. I didn't know it requires lots of substitution to get to the points that we are interested to. Then now, guys, Linda, you said that you were stuck in some points. Which point that you feel that you got stuck there? Okay, I'm gonna start from again here. We said that here we write it like that. Have you written it up to here so far, Linda?
Okay.
You are here. You have written it up to this point.
Yeah.
Yes. Okay. Now that when we are here, I'm gonna go back to the next page. I'm gonna rewrite that line. So far we proved that the cosine of 3 alpha, Arya, it was a very long identity, and if you get a little bit confused, don't worry. It was by nature, it was so much substitution involved.
Okay.
It was 2 times cosine cube alpha minus cosine of the alpha minus 2 times 1 minus cosine squared of the alpha multiplied to cosine of alpha. It's you got to stop there. And before we go for the break, we stopped at this point. Anybody has written this line? Can I start from this? Yes, Linda, have you written that line? Yes?
Yes.
Then I'm going to continue from the right. See what happens. I keep the thing which is 2 times cosine to the power 3 of the alpha where it is. Because that's what I needed. And also, I have minus cosine of the alpha. But look at this point, guys. At this stage, we have something interesting happening. Look at here. I have the cosine of the alpha, which needs to be multiplied in these two terms, correct? Then I have minus 2 cosine of the alpha, because I multiply cosine alpha to 1, and this is multiplied by minus 2, plus minus 2 times minus 1 becomes plus 2 cosine cube of the alpha. You see this, guys? How about you, Linda and Arya? Are you at this stage, Linda?
Yeah.
Yeah? And look here what's happening. I have 2 times cosine power 3 of the alpha, and I have also 2 times cosine power 3 of the alpha. How much they are going to become in total? I have 2 Linda and I have 2 Linda there. How many Linda do I have?
4.
4.
So correct. I have 4 times cosine cube of the alpha, and I have also here minus cosine alpha minus 2 cosine alpha. How much does it become, Linda? I have
Negative
minus
minus
3 cosine of the alpha, because imagine I have 1 area here, 2 area there, it becomes 3 area, but they are minus.
Yes.
That's right.
Negative 3.
That's right. Then what is the left side? I started from this one, that the cosine of 3 alpha. Guys, look at that. What a spectacular job did we do. Look at this. And now we prove the identity. That's essentially what was initially requested for you to do that. Let me see, where is that? Give me 1 second. Look at this. That's the identity which I asked you to prove. 4 times cosine cube alpha minus 3 cosine alpha. And now you have it there. Isn't that beautiful, guys? This identity was a little bit, I should say, it was easier if I wanted to directly substitute the terms, but because I wanted to demonstrate it to you, what's gonna happen, it took such a long time to show that the identity is a valid one and be proved from both sides. I hope that you, when the lecture is done, I hope that you just start from the very beginning and you try it yourself again to show the identity. Okay, everyone? Okay, Linda?
Okay.
Awesome. Okay, Arya?
Yes.
Awesome. Please don't forget to do that. It's a very, very crucial identity. Okay, what time is it now? Today's time was swollen from the things which we do. Okay, now. Let's see what else is left to do. Okay, and now guys, today we do not have enough time to finish it all today, but I'm gonna start the very basic one today. We expand on it tomorrow, but please, how many eyes do you have, guys? How many eyes do you have on your face?
4.
4.
Yeah.
Please, if you have 4, borrow 2 more to have 6 eyes to listen to these concepts, because this is the lessons for the power reduction, and you are gonna get involved into very complex trigonometric, I should say, identities, and you have to reduce the power step by step. Then this identity is very crucial. Please listen to that. We start on it today, but tomorrow we expand on it more then. Then please listen very carefully. Okay. When we talked about, let me change the color of my pen. Let's use this color. The building blocks, guys, of the power reduction identity is going to be the same thing that you learned today. You learned today that the cosine of 2 alpha becomes what? The cosine of the 2 alpha becomes, if you want to expand it in terms of the sine, becomes 1 minus 2 times sine squared of the alpha. And please listen to this, and please look at this one, that this one, as I told you before, it's interestingly very important because you have the double of one angle and you're ending up with one angle to the other side. What I'm going to do now, I'm going to express the sine squared of the half of the angle with respect to the cosine of the alpha. What I'm going to do is going to be this. Then I'm just going to rewrite it to show that the sine squared of the alpha is going to be equal to what? If I just want to use this identity, becomes 1 I take cosine to the other side, becomes 1 minus cosine of the 2 alpha divided by what? Divided by 2, correct? Everyone is fine so far?
Yes.
That's right.
Yes.
And it's going to be the first identity that we are going to work with it to show when we just get to the power reduction and half of the angle identities, that's going to be the first identity. We are going to work with it a lot, especially tomorrow. This is the first identity. And also, how about the cosine of the alpha? We had also the same identity that we talked before what? Before we talked that the cosine of 2 alpha was what? Where is my notes? Look at this one, guys. Identity number 3. We said that cosine of 2 alpha, the third identity says that becomes 2 times cosine squared of the alpha minus 1. Becomes what? Becomes 2 times cosine squared the alpha minus 1. Then as a result, you can just deduce this identity that what is going to be the cosine squared of alpha. What is the cosine squared of the alpha? Becomes cosine 2 alpha, you take 1 to the other side, plus 1. You divide both sides by 2, which is the ratio of this identity. And we get this identity at the same time. Let me also highlight this one. That's going to be your tool. These two identities, guys, from tomorrow, please memorize them because they are going to be your best friends. Your very best friends. These two identities tomorrow is going to be lots of help, I should say. Okay, any questions so far about these two identities? Nothing?
No, no question.
No. I'm just going to use one example in terms of the power reduction. Which page was? Oh, I forgot to number the pages. Okay, let's do this one. As a first basic example, I'm just going to write, let's say, 8 times sine to the power of 4x. Okay. And now, guys, look, what am I going to do and how am I just going to reduce the powers from this identity? Let me write it as an example. Okay, this is the expression which I have. 8 times to the sine of, to the power 4 of the x. Okay. Guys, the first thing which I'm going to do is that I'm going to reduce the power by this. I take whatever coefficient I have to the left, and I write sine to the power 4 of the x as sine to the power 2 of the x, but everything to the power of 2. Because you remember that from function 11, that the exponents is going to work like that, correct? Okay, and now, what's going to happen now? The other thing which I'm going to do is this. I'm going to keep 8 where it is. I'm going to write 8. But guys, I have sine squared of the x, correct? What I'm going to do, I'm just going to use my best friend, this identity, which we derived it today, that sine squared of the alpha equals to 1 minus cosine of 2 alpha divided by 2. That's why I told you it's become your best friend from today now. Then what I'm going to do, instead of writing sine squared of the x, I'm going to write instead the power. We call this the power formula, guys. The power formula becomes 1 minus cosine of the 2x divided by what? 2, correct? Okay. Anyway, everyone is clear so far of the thing which happened? Yes?
Oh, yes. Can
Okay.
you move a little bit more right?
Is it
Okay.
good?
It's good. Thank you.
Okay, no problem. But there is something wrong there, which I forgot to put the power 2 on top. Okay. And now, the thing which happens is going to what? I'm just going to get rid of this one, the exponent there, and I take it to the power 2, take it outside. Then becomes what? 2 to the power 2 becomes 4. Then I have 8 divided by 4 becomes how much? Becomes 2. But instead, I have what here? I have 1 minus cosine of the 2x to the power of 2. Okay, now, what's going to happen here? I'm going to write equals to 2. And I'm just going to use the power identities in order to expand this expression based on the power 2 which it has. What did we have before? We had a plus b. When they go to the power 2 becomes a squared plus 2ab plus b squared. You remember this identity, huh? Then what's going to happen here? I'm going to say it becomes 1 minus 2 times cosine of 2x plus cosine squared of 2x. Everything is good so far? Yes, guys?
Yes.
Awesome. Okay, now, look at this expression. look at just at this simple expression. We have cosine squared of the x again. Okay, now, again, guys, you know what's going to happen. You're going to use your best friend. Who is your best friend when you see the power series? Cosine squared of the x. Cosine squared of the alpha, you learn that. The second best, your second best friend, that the cosine squared of the alpha was cosine of 2 alpha plus 1 divided by 2. I'm going to use the same thing again here. I'm going to use my best friend here. But look at this one. This one is going to be a little bit tricky. Becomes equal to 2. I have 1 minus cosine of 2x plus. For cosine of the 2x, guys, look at that. For cosine squared of the alpha, you had 2 alpha, which this identity shows to you that for your argument, if this is alpha here, you have to multiply it to 2 to get to your, I should say, to your power formula then. If your current argument here is 2 times x, when you use your power formula, it becomes 1 plus cosine of 2 times of 2x becomes how much? 4x, correct? Divided by 2. So far, so good?
Yes.
Okay, and now, let me go to the next page. I'm going to continue it from here. Okay, now, I have 2 here at the left, and I have this one here. Let's take, I should say, the exponent 2. Let's take the common denominator 2, which is going to be 2 here. Then it becomes 2 minus 2 times cosine of 2x plus 1 plus cosine of 4x. I didn't do anything except that the last expression which I got, I used I should say I used 2 here to write the common denominator. Then simply you see that these 2 and these 2, they are going to be gone. Then I'm left with what? Then I'm left with 2 minus 2 times cosine of 2x plus 1 plus cosine of 4x. I have 1, I have 2 here, then becomes what? Becomes 3 minus 2 times cosine of 2x plus cosine of 4x. What was that supposed to be? It was supposed to be my question that 8 times sine to the power 4 of the x. What is that? And we ended up with this very interesting identity. I'm going to highlight it around. Before I explain what happened. Okay, guys. Any questions so far? Before I tell you what happened? Hello? Nobody has a question?
No question.
Okay. Guys, tomorrow we're going to talk more about that, but today, the thing which happened. Guys, look at these 2 identities. I finished the class by this very simple conclusion. Look at these 2 identities which we learned today. We call them power identities. Why they are good for? Look at this one. I have sine to the power of the 4x. But by using those identity successively, I was able to express this expression, which has the power 4, into a sum of expression that all of them has a power of 1. It means that I reduce the power to 1. It is very important in future lessons that how to reduce the power of an identity to smaller powers then. And this is called power reduction technique. We are going to talk more about that tomorrow and have more example on that then. That's a very important lesson. Any questions?
No. Oh, one question, teacher.
Yeah, sure.
The presentation, the PowerPoint, I just send you to your email, or I need to submit on the Schoology?
Oh yeah, Arya, please do not send anything to my email because it gets lost. All I send to Schoology, but for your, I should say, for your lectures, you had 2 assignments. It was due yesterday. One of them was for, I should say, you had 3 homeworks. One of them was the homeworks on the weekend. The other one was a project of the radioactive decay. And the other one was on Hodgkin-Huxley model of the brain. Please, for both of them, post it onto the Science Club.
So why is the 800 word essay?
Sorry, what?
And so totally have 2 assignments I need to submit, right?
That's right. Actually, 3
Why
assignments.
is
1 assignment, 2 projects.
also the 2 projects? One is the report, 800 word,
That's right. And the other one,
and the other one is the PowerPoint.
that's right, that's right. Please you have an account with the Science Club, huh?
What? Sorry.
You have an account in the Science Club on the blogging website.
Accounting?
No, I mean, do you have, are you in the Science Club, the website?
Oh, the website.
That's right. You have to post your homework onto that website then.
Oh, okay. I asked
Previously, I have sent
maybe.
an email as a notice on the course website to explain how to get in there, how to get into that website then. Please review that notice. If you got any problem, send an email to me on the Schoology. I help you to just get into the mail site then. Okay?
So the project I need to send on the online, right?
That's right.
Okay. I will send to
And
you
also, Arya, you have to present 2 of your works to the class. Tomorrow, I give you a date that you can prepare your work. Then you share your screen and talk about your work to the other students.
tomorrow. I need to presentation.
No, not tomorrow. Tomorrow I give you a date for it.
Okay.
Okay. Not tomorrow. Tomorrow I give you a date. Nothing's gonna happen tomorrow.
Okay. The report I need to presentation.
That's right.
800 word.
That's right.
Oh, okay. I will prepare.
That's right. I think it was
Thank you.
500 words or 800 words.
You see 800 words.
I said 800. Okay, 800 is just 2 pages. Less than 2 pages becomes 800 then.
Okay.
Yeah. Any other questions, guys?
No.
No, nothing. If you have no questions, guys,
Oh.
stay tuned tomorrow. Tomorrow we have more lessons of the power reduction technique. Then I see you all tomorrow then.
Okay.
Thank
Bye.
you, everyone. Have a nice
Have
day.
a good day.
Thank you. Take
Bye.
care, everyone.
Bye.
Goodbye. Bye-bye. Bye.